So I'd like to get some ideas in your head before I jump into the real example. Imagine we have an economy for Leontief land, we'll call it. Here I've selected a couple of examples of economic sectors like energy, food, and water. In a real life economy, each one of these sectors are codependent on one another. For example, the food industry is going to need water to grow their crops with. The oil rig is going to need food to feed its employees. Of course, in a real economy, there's many more sectors to deal with, but for the sake of simplicity for this example, I'm just going to use 3 sectors. So the Leontief model is a way of expressing these economic relationships with linear equations and matrices. This particular model is named after its creator, Wassily Leontief. He was a professor in economics. He created this model in the 1930s, and it represents economy as a system of linear equations. And linear equations and linear systems is what we've been dealing with this entire class, so I think it's quite a fitting application. He used it to model the United States economy by dividing it into 500 distinct sectors, and it won him the Nobel Prize in economics in 1973. Okay, so here's our example. Suppose that the economy of a certain region depends on 3 industries: service, electricity, and oil production. Monitoring the operations of these 3 industries over a period of 1 year, we were able to come up with the following observations. To produce 1 unit worth of service, the service industry must consume 0.3 units of its own production, 0.3 units of electricity, and 0.3 units of oil to run its operations. To produce 1 unit of electricity, the oil generating plant must buy 0.4 units of service, 0.1 units of its own production, and 0.5 units of oil. And finally, the oil production company requires 0.3 units of service, 0.6 units of electricity, and 0.2 units of its own production to produce 1 unit of oil. The best way to go about solving this example is by using the given information to form a system of equations. This is a closed economy, meaning that no goods or services enter or exit the economy. From this, we know that the total consumption of each industry has to equal its total production. If you keep that in mind, we can make the following system. As we've done with many other linear systems in this class, we can create a matrix from the consumption coefficients, and we can use that to represent the system with the equation AP equals P, with A equal to the coefficients in a matrix and P equal to P1, P2, P3. We know from earlier in the semester that this statement is true, that AX equals X can be rewritten as A minus I times X equals 0. This means that if we can find the matrix A minus I, augment it with zeros, and row reduce, we can solve for our demand vector P. And that's what I intend to do. So A minus I is going to be A minus the identity matrix, which simplifies to the following. Now we're going to take this A minus I matrix we've just found and we're going to augment it. And we're going to take this augmented matrix and we're going to put it in row reduced echelon form. This should give us a new system of equations, and the lack of leading one on the P3 column lets us know that P3 is a free variable. It means that the goods and services of this economy are tied to oil consumption. So we're going to set P3 equal to some parameter because it's a free variable. I'm choosing T. And then we set P1 and P2 equal to T. And that lets us solve for our demand vector P. And that yields our final answer.